The day when we shall know exactly what electricity is will chronicle an event probably greater, more important than any other recorded in the history of the human race. The time will come when the comfort, the very existence perhaps of man, will depend upon that. Nikola Tesla. This video will be an attempt at articulating a number of ideas which I have been attempting to weave together with the intent of moving towards clearly and cohesively conceptualizing the ontological status of physicality in relation to metaphysics and consciousness. There's a great deal of work to be done here in terms of weaving this conceptual scheme together into a coherent narrative. I'm going to be drawing upon a very wide range of thinkers who have provided the puzzle pieces which I will be attempting to assemble, and as such, what follows may initially seem somewhat disjointed until those pieces begin to fall into place and connections begin to become more clear. Our last video was largely deconstructive in nature. My intent was to illustrate the numerous conceptual contradictions and empirical inadequacies which are inherent within the prevailing Einsteinian worldview. Of course, this exposition was, very predictably, met with the same tired arguments which one would expect. Sure, the Einsteinian models might be empirically false and logically inconsistent, so we are told, but your arguments amount to nothing unless you can come up with a better theory. So, today, my friends, we are going to be doing exactly that. Not by concocting some outlandish mathematical fantasies, exotic quantum entities, unobservable dimensions, or jargon-riddled word salads, but rather by simply taking the pieces which are already right in front of our eyes and attempting to carefully bring them together into something which is actually cohesive and concordant with both human experience and the natural world around us. Of course, there are going to be those who see this as extremely arrogant. How could I, some random YouTuber, possibly think that I could crack the code of the universe when so many other great minds have failed? But the reality is that I personally haven't needed to crack much of anything. Most, if not all, of the necessary insights have already been right in front of us for a very long time. What is needed is for those insights to be properly assembled, and the faculty needed to do so is that of imagination, not genius. As indicated at the end of the previous video, I believe that in order to do this, we must begin by returning to the fork in the road, which has led modern science into the cul-de-sac within which it has been chasing its own tail for the past century. We must begin, that is to say, with electromagnetism. The Maxwell-Faraday equation, a mathematical representation of the principle of mutual electromagnetic induction, shows us that the motions of magnetic fields generate electrical fields, and that flowing electrical currents generate magnetic fields. This principle of electrodynamics is perhaps one of the greatest triumphs of science, as it was through this understanding of electrical and magnetic complementarity that physics was able to realize that electromagnetic waves are able to self-propagate due to the mutual induction of the electrical and magnetic constituents of such field perturbations. Electricity, magnetism, and light were thus revealed to be different manifestations of the same underlying unity. But many questions remained unanswered following the revelations of electrodynamics which were disclosed over the course of the 19th and early 20th centuries, and these unanswered questions remain almost entirely unaddressed within contemporary physics. Rather than providing us with a cohesive interpretation of electromagnetism, modern science has instead come to bury these questions beneath a tangled maelstrom of unobservable particles and mathematical models which essentially lack any ontological grounding whatsoever. That is, physics has become a discipline of wrestling with mathematical abstractions, which now lacks any coherent methodology of even attempting to understand the reality which necessarily underlies such abstractions. The very premise of scientific empiricism, however, amounts to the conviction that nature can in fact be understood. The scientific endeavor itself issues forth from the insight that the human mind is in fact continuous with nature, and therefore that the compositional architecture of the human intellect and the compositional architecture of nature must be grounded in the same fundamental motifs. Insofar as we abandon this epistemological, ontological, and indeed spiritual conviction, we abandon the very endeavor of scientific empiricism itself. And yet, within the epistemological presuppositions of scientific naturalism, we do find a central tension, which has haunted science throughout the entire course of its development. The project of scientific inquiry necessarily insists that the groundwork of human understanding must be found within experience, within our actual encounter with the natural world itself. This emphasis upon the experiential has quite often translated into an insistence that the sensory is the primary bearer of true epistemological weight. Nonetheless, the endeavor of science also necessarily implies that we must move beyond the sensory in order to ascertain the formative, compositional features of the natural world. David Hume's radical skepticism provides us with perhaps the clearest articulation of this problem and its consequences. Hume took very seriously the notion that any and all knowledge which we have of the external world must be derived from sensory experiences. In following through on the implications of this notion consistently, Hume arrived at an utterly dissolutive epistemological skepticism. If our knowledge of the natural world is limited to the sensory, then any and all inferences which go beyond the bounds of the sensory must be regarded as being in some sense irrational, or at least irrational. We may have seen the sun rise every day up until now, but to infer that the sun will necessarily rise tomorrow based on such prior sensations is to go beyond sensation itself. We must inductively infer that this uniformity of nature represents a consistent pattern which will continue to perpetuate itself. We must infer that there is a compositional order which underlies such regularity. Yet David Hume saw very clearly that such compositional elements are never encountered by the human sensorial faculties. We cannot see or touch the Newtonian principles of motion or any other such compositional features of nature. It would seem that we must infer the reality of such formative aspects of nature, yet David Hume saw no way to rationalize such inference. We can deductively arrive upon truths which relate ideas to one another, but Hume saw such ideational contents as aspects of the human mind, not of the natural world, and thus saw no means by which the human mind could rationally deduce the principles of nature which were sought by the project of scientific empiricism. Hume saw that the human mind could experience the sensory realm of corporeal actualities, but he saw no means by which the human mind could make experiential contact with that which gave rise to such corporeal facts. He saw no means by which the human mind could actually experience the suprasensory. In the wake of Hume's skepticism, Immanuel Kant would attempt to address this problem through his distinction between the phenomenal and noumenal realms of reality. Kant argued that the human mind never truly encountered the world as such, but only ever representations of the world, which were conditioned by the human mind itself. Within this Kantian world picture, the human mind is necessarily locked within the bounds of its own perspectival limitations. The world itself is forever outside of our grasp. Therefore, any inductive inferences, including scientific inferences, can only be justified in terms of the way that the human mind necessarily organizes our experience of the world. We can make inferences in terms of categories such as time, space, and causality, even though we never directly experience these entities as sensory contents in themselves, because these entities are in fact categories of experiential organization which the human mind necessarily employs in giving structure to its own experience. Within such a Kantian paradigm, we become forever sealed within the bounds of our own perspectival reference frames, unable to actually make any real contact with the world which we are inextricably interwoven with. Kant's solution to the problem of Humean skepticism was to ask what the human mind must necessarily be like in order for our experience of nature to be what it is. Friedrich Schelling, one of Kant's most notable successors, came to flip this question upside down, or rather right side up, in asking what nature itself must be like in order for human consciousness to be what it is. Schelling saw clearly that the Kantian paradigm threatened to lock the human intellect within an inescapable prison of its own making. Thus, Schelling sought to reclaim our connection to nature through an understanding that the basic compositional features of nature and the basic compositional features of human consciousness must necessarily share in an underlying identity, given that human consciousness is in fact an expression of the same underlying order which we encounter in the natural world. But perhaps the most striking articulation and indeed practical enactment of a post-Kantian empiricism is what we find in the works of Schelling's contemporary Johann von Goethe, who developed and practiced a form of scientific naturalism which radically stepped beyond the bounds of the Kantian prison. On July 20th, 1794, Goethe and the philosopher Friedrich Schiller attended a convention at the Jena Natural Research Society. Following this meeting, Goethe and Schiller began an intense conversation regarding the nature of the world, of philosophy, and of science. This conversation eventually made its way back to Schiller's residence, where Goethe took a pen and paper and began to sketch an image of what he had come to call the Orpflanz, the archetypal plant, which Goethe believed to be a sort of compositional architecture, which was expressed in various ways throughout all of plant life. Goethe claimed that he had come to quite literally see this archetypal formation through his study of botany. Goethe had come to see that all of the various morphological characteristics found throughout plant life were in fact different elaborations or expressions, which were all outgrowths in various ways of the same underlying archetypal form, namely the leaf, the primordial form or phenomenon of all flora. Upon seeing this drawing of the Orpflanz, Schiller disputed Goethe by saying that this Orpflanz was an idea, not an observation, to which Goethe replied that he was very fortunate to be able to see ideas with his own eyes. Goethe's empiricism was one which sought to actually see the inner workings of nature, not through the senses alone, but with the inner vision of imaginal, noetic insight. Notice here that Goethe's Orpflanz doesn't really show us anything that we don't already encounter when observing corporeal plant life. What we see within the Orpflanz is what we already see in nature. Goethe's insight is not a revealing of something which is utterly transcendent per se, in the sense of being completely untethered from the natural world, but rather it is the realization that in seeing natural forms such as stalks, leaves, and flowers, we are already looking at expressions of this underlying phenomenon. The phenomenon is not separate from the sensory, but it is rather that which gives rise to the sensory, as the sensory is the activity of the formative, and the formative is this informing of the sensory. Goethe's insight was thus an ability to transcend the sensory by recognizing what the reality of the sensory actually amounts to. In seeing the Orpflanz, we are seeing the patternicity, or ideational contents, which underlie and condition the particular physical iterations which our sensory organs encounter. But Goethe's experience of primordial forms, or phenomenon, is fundamentally no more than an elaboration of the exact same activity of recognition which occurs during ordinary sense perceptions. Even modern cognitive science has come to show quite definitively that even our most basic sensory faculties can provide us with no more than mere noise in absence of pattern recognition. In order to even perceive our visual field as an experience of distinct objects, we must be able to recognize patterns, and in doing so, we must see beyond that which is provided by our senses in order for the sensory to be intelligible at all. All recognition, in other words, is pattern recognition. Therefore, all experiences, including the most mundane sensory perceptions, are only able to be perceptions insofar as they are an experience of forms, which transcend that which is immediately available within the senses. In order to recognize a tree as a tree, my mind must be able to recognize that the form of the tree delineates it from the other entities within my visual field. In actually seeing the tree as a tree, I must also see the backside of the tree which is physically hidden from my eyes, and I must be able to see the roots that are hidden from my eyes by the soil. Of course, we typically are not consciously aware of such pattern recognition or noesis in our everyday perceptions. These apprehensions of form typically occur beneath the surface of our conscious awareness and conscious agency. They seem to occur in a largely unconscious, habitual manner. But within scientific thinking, we raise this faculty from the depths of our psyches and into our conscious experiences. We begin to actively wield this faculty as an instrument by which we are able to actively participate in the disclosure of the world. The ultimate aim of science, the ultimate spiritual destiny of science, lies in the incorporation of such noetic insight into our sense of conscious agency and selfhood. Our conscious agency is always already engaged in a noetic disclosure of the world, but through scientific naturalism, this capacity for disclosure becomes something which our locus of individual selfhood is able to actively do, rather than something which simply happens to us. What this implies, therefore, is that the Humean interpretation of empiricism as the epistemological predominance of the sensory is in fact an ideology which is fundamentally in contradiction with the very notion of science itself. As we shall see, the Kantian and materialistic ideologies which came to take possession of scientific thought were ultimately no more than elaborations and obfuscations of this underlying contradiction. In parallel with the Kantian duality of the phenomenal and noumenal realms within philosophy, the world of science came to be dominated by what was effectively the same duality in slightly different form, the duality of mind and matter. This distinction initially began with René Descartes, who came to regard the world beyond human subjectivity as a realm of inanimate, inert material substance. Mind came to be understood as fundamentally subjective, while matter came to be defined, in contrast to mind, as the purely objective. Descartes thus set in motion the paradigm of mechanistic materialism, which would eventually come to fully dominate the scientific understanding of the world in general. Within this duality of mind and matter, we find essentially the exact same paradoxes which we find within the Kantian duality of phenomena and noumena. If matter constitutes a purely objective world which exists independently of our subjective experience, yet we only ever encounter the world through subjective experience, then it follows that we never actually encounter matter at all, but rather only subjective representations of matter. Here it is the French philosopher Henri Bergson who can show us the way out of the fly bottle. Within his text Matter and Memory, Bergson moves beyond this materialistic trap by simply following through on materialism's own internal logic. Bergson asks us to consider what exactly we mean when we say that an object, like a candle for example, is made of matter. One thing we might be saying is that the candle is not merely an illusion or hallucination. It can be experienced by many different observers. I can look away from the candle and go into a different room, but when I return, I will once again experience the candle. The candle's matter then must refer to the aspect of the candle's existence, which is not identical with any particular subjective experiences of the candle. The candle's matter must somehow be that which is behind or beneath our particular experiences of the candle. Bergson then tells us that if we are to be truly empirical about this problem, then we must not conjecture matter to be anything other than that which we actually experience empirically. If we are true to empiricism, then we must admit that we are left with only two categories: our particular experiences of the candle which have already occurred, and possible experiences of the candle which could occur. As we have already concluded that matter cannot consist of particular experiences, we are forced to conclude then that the candle's matter must consist of possible experiences which could occur but which have not yet occurred. Matter, Bergson concludes, must therefore be understood as consisting of virtuality, or potentialities, rather than of an ephemeral stuff which is supposed to lie always just beyond the reach of our consciousness. The candle's objective reality consists in the fact that it is an inexhaustible well of possible relationships which could come to manifest between the candle and other things in the world. Insofar as we are being true to empiricism and thus limiting ourselves to that which we actually experience, then we have no grounds for presuming that any of those possible relationships are lacking in subjectivity. Simply by being consistently empirical, we are forced to conclude that the actual relationships which comprise the world must be experiential relationships. Much as with Goethe's recognition of the Urphänomen, Bergson shows us the way out of the Cartesian and Kantian traps through the insight that our physical sensations are experiences of suprasensory, formative structures of potentiality which both transcend and condition the sensory. A formative realm which we are always already in contact with, as sensory experiences themselves are such points of contact. The mind comes to see the suprasensory through the realization that the sensory is the activity of the suprasensory, rather than by conjecturing the existence of something which is forever beyond our faculties. We can understand this Goethean and Bergsonian insight as a kind of naturalistic elaboration of the same underlying Platonic understanding of reality which has conditioned Western thought throughout the course of its development. When we look at a circular object, such as a clock face, we are not simply encountering the clock face itself. In order to even recognize the clock face as a clock face, we must also recognize that we are encountering the form of the circle. The form of the circle is a suprasensory form. It is a potentiality which is able to participate in the formation of actuality. Within traditional Platonic metaphysics, forms such as the form of the circle are understood to be entirely transcendental. The world of forms is understood to be perfectly pure, necessary, and eternal, in contrast to the immanent, material realm of imperfection, contingency, and temporality. The form of the circle is understood to be something entirely separate from the particularity of the clock face. Yet if we look back to our Bergsonian analysis of the candle, we can see that this naturalistic Platonism is now quite different in certain pivotal regards from traditional Platonism. It is now the very materiality of the candle which is now regarded as formative, as a distribution of possible relationships which comprise the objective reality of the candle. We can begin to understand the candle in itself, the candle which resides behind our particular sensory experiences, as a kind of field of possible sensations, possible relationships which might come to be actualized as the candle participates in composing the architecture of the past from the building blocks that are possible futures, formative structures of potentiality. The next building blocks which we must put into place are those provided by the English mathematician and metaphysician Alfred North Whitehead. Much like Goethe and Bergson, Whitehead came to see that the scientific paradigm of mechanistic materialism had become hopelessly inadequate for the purposes of coherently interpreting the actual facts of the natural world which science itself had come to reveal. A novel mode of thinking would need to be developed in order to ameliorate this inadequacy, and within the pages of his 1927 Process and Reality, Whitehead attempted to provide us with just such a novel mode of scientific thought. Whitehead came to see that one of the most fundamental flaws which had come to handicap science and philosophy was the presumption of substance materialism. The presumption that reality must be understood as consisting fundamentally of self-persisting physical objects, which are characterized by spatially distributed geometric surfaces. In other words, the notion that the world is made up of some sort of physical stuff, which amounts to a fundamental substrate of building blocks out of which the world is composed. In contrast to this substance materialism, Whitehead's process metaphysics is one which conceptualizes the world as consisting fundamentally of events or processes, rather than physical objects. Whitehead designates the basic units of the natural world as actual events, actual entities, or perhaps most provocatively, electromagnetic droplets of experience. As we can see within Whitehead's use of the term experience, Whitehead also came to reject the Cartesian mind-matter dualism which had come to dominate scientific thought, once again paralleling the thought of Henri Bergson and many others. Within Whitehead's process-relational ontology, each actual entity comprising the world is a moment of concrescence, a fundamentally organismic process by which a complex of experiential relationships is brought together so as to self-generate a determinate moment of concrete actuality, which is then incorporated into the past. These droplets of experience consist of two fundamental poles, one consisting of physical experiences and the other consisting of conceptual experiences. Physical experiences are akin to sensations. They are the incorporation of past actualities into a currently self-generating moment of reality. When dominoes fall and knock one another over, we can see that the structure of a past event, the first domino falling, then contributes to the determination which will be realized within the next moment, the second domino falling over. There is an inheritance of the concrete actuality which has already come to be established in the formation of the previous event. Conceptual experiences, on the other hand, are feelings of potentialities or forms, or what Whitehead would refer to as eternal objects. They are noetic experiences, or noemata. For any moment of organic self-organization, the organism will experience an indeterminate range of possibilities which will come to be carved down or selected from through the self-generative process of concrescence. The organism will feel the possibilities available to it as conceptual prehensions, and these conceptual experiences will then be interwoven with the physical inheritances of past actualities, thus coming to achieve a novel moment of concrete determination. A self-determining decision is made, and this decision then becomes incorporated into the architecture of the cosmos. For Whitehead, these organismic or concrescent processes are not limited to biological organisms. Within the framework of materialism, we tend to presume that the world consists primarily of dead, inert matter, and that organicity is an emergent phenomenon which somehow arises on top of such a substrate of inanimate physicality. Whitehead instead shows us that in order to account for the reality of the natural world around us, we must flip this conception upside down. We must come to see that the world fundamentally consists of self-generative, experiential, symbiotic, and animate processes. We might assume that when looking at a mundane rock that we are looking upon mere matter, but in reality the rock itself is an aggregation of innumerable organismic entities, atoms and molecules which have come to form a stable structure which only appears to us as being inert due to the fact that in such a state the atomic and molecular organisms are making essentially the same decisions over and over again. They are simply self-perpetuating until some other factors come into play which can evoke the truly organic dynamism which is hidden within the rock. Within Whitehead's model of organic processes as polar systems of conceptual and physical poles, we can see a polarity of indeterminate fields consisting of felt possibilities and concrete interactions between such fields, a polarity of sensation and noesis, concreta and noemata. As we shall see later on, it is through this distinction that we can begin to render intelligible the supposed wave-particle duality of the electromagnetic realm. According to Whitehead, it is through this polarity of fields and transmissions that the material substrate of our world comes to arise, not the other way around. As these fields and transmissions come to be interwoven into self-perpetuating, recursive knots, the cosmos comes to achieve the generation of the first organisms which are able to approximate the properties which we attribute to the notion of material objects. Insofar as conceptual fields of possibility precondition the actualization of concrete physical transmission events, we can see once again that the sensory is the manifest activity of the suprasensory. Despite the pronounced tendency within modern science towards a predominantly sensationist understanding of empiricism, the endeavors of science would inevitably bring themselves into contact with the suprasensory realm, most notably through the developments of electromagnetic theory, which would come to drastically alter our understanding of the natural world over the course of the late 18th and 19th centuries. As the project of modern science came to truly rise to prominence during the 17th and 18th centuries, electrical and magnetic phenomena were largely understood as strange curiosities. Researchers discovered ways in which electromagnetic phenomena could induce shocks as well as attractive and repulsive forces. But these phenomena, though appearing almost supernatural, were regarded by most as being parlor tricks more so than as representing a core concern of scientific investigation. Though significant advances were made by investigators such as William Gilbert and Robert Boyle, the true technological, scientific, and indeed metaphysical significance of electromagnetism remained a faint glimmer upon the horizon which had yet to come into focus. But within the closing decades of the 18th century, a number of monumental advances would begin to truly illuminate the power and ubiquity of electromagnetic phenomena. This was a period of monumental transformations in virtually all domains of Western culture, transformations which would eventually germinate so as to form virtually all of the features of our current world which we consider to be truly modern. Adam Smith's Wealth of Nations would lay the groundwork for modern capitalistic economic theory. The American and French revolutions would lay the groundwork for the political dynamics of modern liberal democracy, as well as the left versus right polarization of modern culture. Immanuel Kant's critique of pure reason would condition the emergence of the German phenomenological tradition, as well as the later development of analytic philosophy in the English-speaking world. At the same time that these groundbreaking developments were taking place in other areas of Western thought and culture, so too did the study of electrodynamics begin to come into its own as a central concern of scientific thought. In 1785, Charles Augustin de Coulomb would formalize his investigation of electrostatic force, resulting in the establishment of a fundamental principle now known as Coulomb's law. Coulomb's principle of electrostatic force interaction shows us that the powers of such forces behave in accordance with the inverse square law, the exact same mathematical relationship which Isaac Newton had discovered to be an underlying principle of gravity. This seemed to strongly suggest that there must be some underlying unity of electromagnetic and gravitational phenomena, but this provocative isomorphism would remain a riddle which science found itself unable to render comprehensible. In 1800, Alessandro Volta would create a device which we now know as the voltaic pile, the first chemical battery which was able to induce a steady, flowing current of electricity which behaved in a seemingly liquid manner. Rather than merely static forces of attraction and repulsion, it was now becoming clear that within electromagnetic phenomena there was something which was able to flow between objects. Yet this mysterious something seemed to be drastically different from the physical matter which science had presumed to constitute the natural world. This electromagnetic fluid seemed to be something utterly intangible, and yet it was now clear that this mysterious something held a power which humanity might come to wield in truly spectacular and ultimately world-reshaping ways. During the same time period, the experiments of Luigi Galvani would come to reveal that electromagnetism was not simply a property of chemical fluids and metallic artifacts. Galvani's experiments upon the corpses of frogs demonstrated that biological organisms, even those that were no longer living, seemed to be animated by some sort of vital power which was somehow electromagnetic in essence. Galvani saw a fundamental unity of the flows of electromagnetic forces and the metabolic, circulatory, and respiratory flows which animated biological systems. Galvani would come to develop a notion of animal electricity, thus laying the groundwork for the development of what we would now refer to as bioelectricity. Galvani's work suggested that there must be some sort of fundamental unity between electromagnetism and biological animacy, but much like Coulomb's riddle of electromagnetism and gravity, this riddle of electromagnetism and biology would largely remain an unsolved mystery. This mystery would come to be almost entirely forgotten following the discovery of the DNA helix during the mid-20th century, as the neo-Darwinian paradigm would come to understand life in terms of mechanistic chemistry, with bioelectricity coming to be relegated to an entirely tangential role, if not to the trash bin of so-called pseudoscience. As the 18th century gave way to the 19th, novel developments would reveal even more of the inner workings of the electromagnetic realm, and further deepen the mystery of its fundamental nature. The English physicist and chemist Michael Faraday would produce numerous insights regarding electromagnetic induction, electrochemical processes, and the capacity for magnetic fields to influence rays of light, a discovery which would be the first indication of a fundamental unity between light and electromagnetism. Perhaps most significantly, however, was Faraday's introduction of the notion of electromagnetic fields. Faraday conceptualized electromagnetism as consisting of distributions of invisible lines of force through which electromagnetic energies would flow. Faraday came to see that magnetic phenomena came about through dynamics of congruity or incongruity between such flows of energy. Magnetic forces were understood by Faraday to flow outward from the north pole of a magnet and then converge into the magnet's south pole. When the north and south poles of different magnets were brought together, these flows would merge together so as to form a singular, continuous circulatory system. When like poles were brought together, however, these flows would instead repel one another. In the mid-19th century, the Scottish physicist James Clerk Maxwell would come to unify the various mathematical principles of electrodynamics into a unified model which we now know as the Maxwell equations. Through his mathematical calculations, Maxwell came to realize that the mutual induction of electrical and magnetic fields would result in a self-perpetuating propagation, which was predicted to flow at exactly the same speed as the empirically measured speed of light. Maxwell thus came to reveal that light itself was indeed a form of electromagnetic propagation. Despite this plethora of profound insights and the mathematical perfection of Maxwell's unified models, there yet remained the fundamental question of what electromagnetism actually amounted to ontologically. What did these fields actually consist of? What actually flowed along Faraday's invisible lines of force? What was the underlying medium which was undulated by the propagation of electromagnetic waves? As the science of electromagnetism came to develop, these questions only seemed to become more intractable, as electromagnetism came to appear as a paradoxical chimera of wave-like and particle-like qualities. The notion that electromagnetic energies could be understood in terms of discrete units initially emerged during the late 19th century with the works of Irish physicist George Stoney, who coined the term electron to describe this hypothetical unit of electrical energy. Shortly thereafter, the British physicist J.J. Thomson would perform experiments involving cathode ray tubes, which were taken to imply that electrical energies consisted of discrete corpuscles, which later would come to be understood as particles. Yet, in contrast to this evidence of a particle-like nature of electromagnetism, other evidence seemed to clearly indicate that these phenomena were fundamentally wave-like. Double-slit experiments demonstrated very clearly that electromagnetic propagations could manifest interference patterns, much like those seen in other kinds of waves. Electromagnetic propagations also seem to be clearly characterized by wave-like properties such as frequency and wavelength. In the year 1900, Max Planck's work regarding black-body radiation would result in his conjecture that electromagnetic energies could not be truly continuous, but rather were necessarily confined to discrete energy levels, which were determined by the relationship between frequency and a specific numerical value, which we now know as the Planck constant. In 1905, Albert Einstein would build upon Planck's work to address the problems presented by the photoelectric effect. In doing so, Einstein would introduce the notion that electromagnetic propagations occurred as discrete quantum entities, which would later come to be called photons. These revelations would thus lay the seeds for what would later unfold into the quantum revolution. Yet even as evidence continued to mount which suggested a particle-like nature of electromagnetic phenomena, the wave-like properties of electromagnetism would not simply disappear, and further developments would only come to reinforce this bizarre duality. In 1924, the French physicist Louis de Broglie would present within his PhD thesis a conception of electrons as being spherical standing waves of electrostatic energy. De Broglie's standing wave model further reinforced the wave-particle duality introduced by Planck and Einstein, as de Broglie demonstrated that the discrete, quantized nature of electrostatic energy worked in conjunction with the stability requirements of spherical harmonic modes, such that the electronic shells surrounding atoms were organized into specific energy levels. It is here that we come to an impasse in the history of physical science. The paradoxical nature of wave-particle duality was never resolved. Physicists of the early 20th century simply did not possess the conceptual tools needed in order to actually reconceptualize nature in such a way that their ontological assumptions could be brought into accordance with the reality of electromagnetism. Over the course of the 19th century, the paradigm of mechanistic materialism had come to almost completely solidify as the dominant metaphysical purview of scientific thinking, and science had increasingly come to amputate itself from philosophy as a whole. As such, natural philosophy had become almost entirely unconscious of its own underlying philosophical presumptions. Science continued to speak of electromagnetic phenomena in terms of particles, thus insinuating an ontology of mechanistic materialism, but science could no longer even say what the word particle was actually supposed to mean. Words like physical, material, and matter remained within common scientific parlance, but these had become dead metaphors. It was understood, at least by those who took the empirical reality seriously, that these terms had essentially become provisional placeholders, which obfuscated a much more subtle underlying ontology, which clearly did not accord with materialistic presuppositions. These materialistic ideas were now clearly oversimplifications which glossed over a very different underlying reality. Yet the question still remained: an oversimplification of what exactly? The very disheartening truth about these questions is not that they were so difficult to answer that no one could ever truly understand them. The truth is simultaneously much more optimistic and much more cynical. Science never achieved any real answers to these questions because, following the developments of the mid-20th century, physical science essentially came to completely abandon the possibility of even attempting to achieve coherent explanations of natural phenomena at all. Prior to the Second World War, natural science had been largely predominated by two major epicenters, one in Germany and the other in Britain, and thus the pursuits of natural science were heavily conditioned by the intellectual traditions of those two cultures. The British intellectual tradition was, and still remains today, colored by a very particular understanding of the significance of human rationality. The British intellectual tradition saw itself as using the cool, calculating powers of logic and reason to impose order and overcome superstitious, barbaric dogmas. British intellectuals saw intellectualism itself as a signifier of class, prestige, and aristocratic nobility. This tradition saw the world as fundamentally comprehensible, and that such comprehension was to be achieved through the clarity and mechanical rigor of analytic, procedural thinking. The German intellectual tradition, on the other hand, was always one which was much more deeply interwoven with the arts, humanities, metaphysics, and esotericism. German scientists of the 19th and early 20th centuries traced their heritage directly back to figures such as Kant, Fichte, Hegel, Schelling, and Goethe. Whereas the British analytic tradition tended to see human thought and language in terms of operational procedures, the German tradition always strove to be much more grounded in the living world and the phenomenology of human experience, and much more wary of falling prey to cerebral abstractions at the expense of concrete reality. Following the close of the Second World War, the heart of natural science would come to rapidly relocate to the United States. Germany and Britain were both little more than shattered shells of what they had once been, while the United States had come to emerge as the greatest financial, industrial, and imperial superpower that the planet Earth had ever seen. Moreover, the United States was also an imperial superpower, which, following the development of atomic weapons, had come to see that to financially invest in physical science was to financially invest in devastatingly powerful militaristic technologies. If one wanted to do physics following the Second World War, then the United States was the place to do it. But the intellectual culture of the United States, insofar as we can even call it that, was something very, very different than that of either Britain or Germany. This distinction is perhaps best illustrated by the striking contrast which we see between Nikola Tesla and Thomas Edison. Nikola Tesla was born in the Austrian Empire in 1856 and would work as an electrical engineer in Budapest and Paris, eventually finding work with the Continental Edison Company, which would eventually result in his immigration to New York City. In accordance with the continental tradition which he emerged from, Tesla was always first and foremost compelled by the conviction that nature itself could be genuinely understood by human consciousness. Tesla was a prolific inventor and engineer, but ultimately Tesla's grappling with technological contrivances was an indirect way of grappling with the mysteries of nature itself. In contrast, Thomas Edison, born in rural Ohio, was always first and foremost a pragmatist in the most entrepreneurial and calculative sense of the term. Edison was a businessman who wanted results, and for a businessman, results mean profits. Questions about utility and efficacy were always far more important for Edison than concerns regarding ultimate truths or ontological mysteries. Edison's attitude can be understood as the most capitalized form of the American pragmatist spirit, which we see exemplified by figures such as William James and Charles Sanders Peirce. The more philosophical form of American pragmatism always placed an emphasis on the concrete, lived reality of human existence in a manner that is, in certain ways, very similar to the German intellectual tradition. James and Peirce were deeply concerned with ensuring that truth remained grounded in the world itself, rather than becoming lost within intellectual fantasy worlds. For men such as James and Peirce, truth was found within the living reality of human existence. For a man like Edison, however, the truth was simply that which turned gears, motors, and profits. Following the Second World War, the massive influx of corporate and federal financing of physical science was poured like gasoline upon the Edisonian version of capitalistic pragmatism. Rather than being predominantly a pursuit of eccentric enthusiasts and ancient scholastic institutions, the enterprise of science had now become a professional career path and thoroughly financialized institution which was beholden to corporate and state bureaucratic interests which simply didn't give a damn about whether or not science was actually producing truth. The age of consumerist and military-industrial science was now fully underway. The bizarre logical inconsistencies of physics were no longer seen as problems in dire need of solution. As long as science was able to make precise, quantifiable predictions, then any metaphysical or ontological issues of science were seen to be little more than tangential and inconsequential considerations. The power to make predictions was the power which allowed mathematical equations to become combustion engines, hydroelectric dams, and nuclear warheads. The project of actually comprehending nature, the project which had animated science from its very origins, came to fall by the wayside as shut up and calculate became the mantra of physical science. The figure who most thoroughly exemplified this post-war entrepreneurial version of science was undoubtedly Richard Feynman. Feynman was in many ways the Platonic archetype of the American intellectual. Born in 1918 in New York City to a housewife and sales manager, Richard Feynman would become the most charismatic exemplar of post-war Americanized science. Feynman was highly personable and spoke with a very parochial New York accent, using practical examples and common language to articulate complex scientific concepts. Students and science enthusiasts looked to him as a demonstration of the manner by which the rugged, practically grounded, and unpretentious American spirit could become a spirit of scientific aspirations. The problem with the attitude exemplified and promulgated by Feynman and others like him, however, is that beneath the surface what we find here is a deeply anti-scientific disposition. Feynman consistently insinuated that ontological questions concerning the nature of scientific theories were unanswerable and ultimately an impractical waste of time. Feynman seemed to have been thoroughly convinced that science had simply stepped beyond the bounds of that which was actually comprehensible to the human mind, insinuating repeatedly that the true nature of the subatomic realm was simply incongruent with human consciousness. Feynman believed that although mathematics could allow us to predict and control this mysterious subatomic world, it was nonetheless a world that did not make sense and which didn't need to make sense. Within modern academic culture, we can see that this attitude has now become fully solidified as the standard interpretation of scientific theories, as well as the world they are intended to describe. The paradoxical nature of modern physical models, or in other words, the logical inconsistency of such models, is now almost entirely interpreted as a failure of the human mind rather than as a failure of the models themselves. It is now an almost entirely unquestioned presumption that there is an irredeemable incompatibility between the nature of human consciousness and the fundamental nature of reality itself. And yet, as we have already seen, this presumption is itself directly contradictory to the basic presumptions of the entire project that is scientific naturalism. All natural science necessarily begins with human experience. We begin with the world as we actually encounter it, and then begin to generalize, moving upwards to ever more general and thus ever more fundamental dynamics which actually produce the particular experiences which we began with. Science is a necessarily empirical endeavor, and insofar as we discard the presumption that there is a fundamental identity between the nature of human experience and the nature of the world, we completely saw off the branch we have been sitting upon. We disavow the validity of our own consciousness in favor of technological instruments without realizing that the validity of those instruments is itself necessarily predicated on the theories which produced them. Theories which began with human eyes and hands, not with computers, equations, and radio telescopes. As our technological instruments become ever more complex, ever more theoretical assumptions become built into their very makeup. Beneath that tangled web of presumptions and machines must necessarily be human experience. If we disavow the validity of human consciousness, then we are forced to admit that we no longer have any idea whether the assumptions being built into our instruments are even valid. We are forced to conclude that we have essentially no idea what we are looking at on the other end of our telescopes, because we will have disavowed the very epistemological foundations which have allowed us to even interpret observational data at all. The power to make predictions is not truth. Truth is understanding. I can use equations to make predictions about what numbers will be spat out by my scientific instruments without having the foggiest idea as to why those equations predict those numbers, without having any understanding of what assumptions are literally built into the processes by which those instruments filter signal from noise, and without the faintest idea as to what real processes, if any, might be behind my equations. The ability to make numbers line up with one another is a pathetic excuse for what genuine scientific understanding was meant to be, and if refusing to settle for that version of truth makes me a pseudoscientist, then so be it. In fact, I think there's a rather charming irony in the fact that we now live in a world in which so-called pseudoscience seems to be far more in accordance with what the forefathers of science understood science to be, while academic science has become something that those forefathers would have seen as completely unrecognizable. A convoluted, self-contradiction-riddled thicket of uninterpretable equations is not genuine understanding. A convoluted circus of fantastical, unobservable entities is certainly not empirically grounded scientific naturalism. To be clear, I am not claiming that nature cannot be bizarre. In many ways it certainly is, and very often we find nature to defy our expectations in spectacular ways. What I am saying, however, is that nature must necessarily be in accordance with the basic principles of logical coherence, morphological cohesion, parsimony, and unity which also characterize human thought. The basic compositional elements of nature must be the same formative dynamics which characterize human thought if we are to presume that human thought is in fact a natural phenomenon. Without that presumption of such a basic congruity between the natural world and human consciousness, there can be no genuine scientific knowledge about the natural world at all. Of course, this doesn't imply that I will personally crack the proverbial code and definitively resolve all of the inner mysteries of nature. But nonetheless, we have to start somewhere, and luckily we do have the shoulders of several giants to stand upon. There are no limitations, no bounds to the work of the mind, nor to the scientific imagination. Charles Proteus Steinmetz. When we trace back our steps from the convoluted cacophony that is modern physical science, we quickly find that all roads lead back to one central, fundamental mystery: electromagnetism. Einstein's attempt to contend with the results of the Michelson-Morley experiment led to the development of special relativity, which in turn led to the development of general relativity, thereby laying the foundations for all subsequent astrophysics and materialistic cosmology. Likewise, the wave-particle duality of electromagnetic propagations and electrostatic phenomena would catalyze the development of quantum mechanics and ultimately lead to the development of the standard model of particle physics. But even though both of these primary currents of modern physics ultimately derive from interpretations of electromagnetism, neither of those currents have ever given us a clear conception of what electromagnetism actually is. All of the fundamental questions which haunted science prior to the quantum and relativistic revolutions continue to linger as unaddressed mysteries, but now buried beneath a near impenetrable fog of exotic particles, space-time mysticism, and other such hypotheticals which have increasingly become ever more untethered from the actual world which human consciousness actually finds itself to be a part of. What exactly is a quantum particle? How can the subatomic realm be characterized by both wave-like and particle-like properties? If electromagnetism behaves as waves, then what exactly is doing the waving? Why do electromagnetic propagations seem to behave in ways that defy our expectations regarding causal sequence through time? Why is it that the relativistic and quantum understandings of reality cannot be reconciled? These questions must have answers, but modern physics has nonetheless proceeded as though they do not, as though these are simply unknowable mysteries which defy human comprehension. Although this notion of scientific explanation is now utterly alien to the modern institutional systems we now ironically refer to as science, this was certainly not always the case. Prior to the advent of the Einsteinian relativity framework within the opening decades of the 20th century, the titans of electromagnetic theory did in fact have a working hypothesis regarding what the nature of electromagnetism might actually be. James Clerk Maxwell himself, as well as numerous others such as Oliver Heaviside, Charles Proteus Steinmetz, and Nikola Tesla, all agreed that one conclusion above all was absolutely inescapable regarding the nature of electromagnetism. If electromagnetic phenomena are indeed waves, then something must necessarily be doing the waving. As such, all of these giants of electromagnetism agreed that there must be some sort of etheric medium, with Maxwell and Tesla in particular suggesting explicitly that such an ether must in fact be the ultimate unifying ground which underlies all physical phenomena. But in order to address the nature of such an etheric medium, we must begin by trying to understand what fields actually are, and by extension what the ontological and epistemological implications of electrodynamics must be taken to be. Suppose that an ether strain corresponds to an electric charge, an ether displacement to the electric current, these ether vortices to the atoms. If we continue these suppositions, we arrive at what may be one of the grandest generalizations of modern science, namely that all the phenomena of the physical universe are only different manifestations of the various modes of motions of one all-pervading substance, the ether. The vast interplanetary and vast interstellar regions will no longer be regarded as waste places in the universe. We shall find them to be already full of this wonderful medium, so full that no human power can remove it from the smallest portion of space or produce the slightest flaw in its infinite continuity. James Clerk Maxwell. Electromagnetic fields are invisible, and yet the activities of such fields can be clearly seen and demonstrated. If we follow through upon the epistemological implications of empiricism, here we must then conclude that there is only one viable interpretation, that fields are distributed structures of potential events. Here we are simply using the exact same reasoning which led Henri Bergson to conclude that matter must consist of images or potential experiential relationships. We are making an inference directly from what we can actually see. We have no reason to believe that the invisible is anything other than that which gives rise to the visible, as it is the visible which actually stands in need of explanation. In order to further elaborate upon this conclusion, we can now begin to draw upon the conceptual tools provided by Alfred North Whitehead. Once again, making inferences which are conditioned specifically by the actual experiences which constitute our actual world, Whitehead concludes that the world consists of self-generative, organismic, and experiential processes, and that such processes are constituted by two primary types of relationality: physical relationships and conceptual relationships. As we have already seen, such physical relationships or physical prehensions essentially amount to what we could call sensations. They are experiences of past events which have already come to achieve physically definite determination. Through physical relationships, these already determined physicalities come to impose themselves upon the present, thereby restricting the possibilities which are available to subsequent moments of self-generation or concrescence. When we look to our actual experience of being alive in the natural world, this is exactly what we find. Our sensations are feelings of things that our bodies or other bodies have already done. We are inheriting the structures of previous events which are essentially attempting to repeat themselves into subsequent moments of becoming. Conversely, all of our experiences also consist of feelings of possibility. We find ourselves to be always navigating nebulous distributions of possible decisions. As we navigate such possibility spaces, phase spaces, or fields, these nebulous distributions come to be carved down into the physical, determinate moments which are then incorporated into the past. We can then generalize this framework so as to understand the nature of animacy in general, and by extension, the nature of cosmogenesis in general. The manner in which the universe and the various processes which comprise it come to continually generate and regenerate the world. If we are to consistently follow through upon the implications of Whitehead's reasoning, then we must conclude that electromagnetic fields are in fact fields of conceptual feelings, distributions of possible events or forms, which are felt by electromagnetic organisms. Electromagnetic fields, in other words, are in fact morphogenetic fields. Whitehead's process-relational ontology indicates that the basic structure of the natural world consists of self-organizing events rather than self-persistent physical objects. It is only once these organismic events begin to be woven together into self-perpetuating, cyclical patterns with discrete locations in geometrical space that this underlying animacy begins to express the qualities which we typically associate with physical objects. Through this framework, we can begin to understand the wave-particle contradictions of modern particle physics in a very different manner. The electromagnetic realm consists of two basic poles: continuous fields of possible transmission events and the discrete transmission events themselves, which alter the subsequent morphological characteristics of fields within subsequent events. We should not understand the electron to be a discrete physical BB which can somehow also behave like a wave. Rather, we should understand the electron to be the most basic transmission of electrostatic energy potential between electromagnetic fields. Electrostatic fields, then, can be understood as distributions of such potential transmissions or interactions with other such fields. So now we can begin to ask, what are the basic morphological characteristics of such fields which come to create the empirical phenomena of electromagnetism? How do these fields emerge? How do they interact with one another? And how do they condition the nature of the physical, perceptible world? What, in other words, are the basic dynamics of conceptual, noetic consciousness in general? This image is a diagram which we find within the elementary lectures on electrical discharges, waves, and impulses by Charles Proteus Steinmetz. This diagram depicts the cross-section of a circuit and the morphology of the electromagnetic field which the circuit produces. If this circuit were a simple circular loop, then the corresponding electromagnetic field would assume a toroidal configuration. The solid concentric lines represent the magnetic circulation patterns of the field, while the broken radial lines represent the electrostatic aspects of the field. This is an image of two patterns of concentric wave propagations, which illustrate the patterns of interference between the two propagating fields. Here we can see Steinmetz's diagram imposed upon the wave interference depiction. What we seem to see here is that electrostatic field lines directly correspond to patterns of interference between magnetic fluctuation systems. If the two currents depicted here are moving in opposite directions, as would be the case if the two currents were part of the same circular loop, then the right-hand rule would necessitate that the magnetic circulations between the currents would move concurrently with one another. In this situation, the magnetic fields would repel one another. Conversely, if the currents were moving in the same direction, the right-hand rule would necessitate that the magnetic circulations between the currents would move in opposition to one another, in which case we would observe an attraction between the two currents. With simple bar magnets, we find the exact same dynamics at play. Magnetic circulations flow out of the north pole of the magnetic system and converge into the south pole. When the north and south poles of the two magnets are brought together, the magnetic circulations move in opposition to one another, resulting in an attraction which will attempt to merge the two magnets into a unified magnetic organism. On the other hand, if the north poles of the two magnets are brought together, the magnetic circulations will move concurrently with one another, and we will observe a repulsion between the two magnets. What we are seeing here is therefore a process by which constructive interference between concurrent circulations will give rise to repulsion, while destructive interference between opposing circulations will give rise to attraction. Thus, we can see that magnetic polarity is not a fundamental property in and of itself, but rather an emergent phenomenon which results from dynamics of congruity or incongruity between magnetic circulations. Constructive interference seems to amplify some sort of inherent pressure or density, thereby resulting in repulsion. Destructive interference diminishes such density, thereby resulting in symbiosis. Looking now to the nature of electromagnetic propagation, such as light waves and radio waves, we can see the exact same fundamental dynamics at work. Here we can see that such propagations consist of flowing circulations of magnetism. These magnetic circulations are complemented by electrostatic circulations, which are perpendicular to the magnetic circulations. As we would expect, these electrostatic circulations occur exactly where we would expect to find interactions of constructive or destructive interference between the magnetic flows. What we seem to find here is that electrostatic energy is in fact a kind of tension, unrest, or discordance, which emerges through the interactions of field circulations which are fundamentally magnetic in nature. When I stretch out a rubber band, I am creating a kind of tension and thus creating a kind of potential energy. This unrest will attempt to resolve itself if possible, and therefore, if I let go of the rubber band, it will snap back into a more stable configuration. The potential energy of the tension will be transformed into kinetic energy as the rubber band contracts. Within electromagnetic propagations, therefore, what we seem to see is a recursive dynamic through which the tension created by magnetic interference continually tries to resolve itself and thereby perpetuates the propagation. We can see that fundamentally this is the exact same dynamic we see in waves of water or sound. A disequilibrium of pressure, density, or intensity is created which attempts to resolve itself, and in doing so results in an outwardly propagating flow of disequilibrium. The history of science shows that the progress of science has constantly been hampered by the tyrannical influence of certain conceptions that finally came to be considered as dogma. For this reason, it is proper to submit periodically to a very searching examination principles that we have come to assume without any more discussion. Louis de Broglie. In order to continue piecing together the various nuances of this puzzle, we must now begin to look at the relationship between electromagnetism and physical matter, and thus begin to unravel the mystery that is the electromagnetic nature of the atomic realm. In 1897, J.J. Thomson discovered that atoms somehow contain discrete units of electrostatic energy, which we now refer to as electrons. This would ultimately result in the conceptualization of these electrostatic units as electronic particles, which were believed to somehow orbit the atom in a manner analogous to the way in which planetary bodies orbit the sun within our solar system. This model, despite being somewhat intuitive, was rife with problems. Numerous empirical facts of electromagnetism, as well as the Maxwellian synthesis itself, seemed to present the unavoidable implication that electrostatic energy moved as a wave, not a particle. Moreover, the Bohr model of the atom could seemingly account for the nature of the hydrogen atom, but faltered when attempting to account for heavier elements. Long before the birth of quantum mechanics as we now know it, the paradox of wave-particle duality had already begun to present itself, and further evidence would continue to accumulate on both sides of this conceptual rupture. The de Broglie model of the electronic shell as a standing wave then came to supersede the solar system model, as the de Broglie depiction much better accorded with the empirical reality and allowed scientists to conceptualize how and why electronic shells seem to only form within discrete quantized energy levels around the atomic nucleus. The fundamental, quantized properties of these electrostatic energy units conspire with the harmonic stability conditions of spherical standing waves so as to constrain the possible range of stable forms which the electronic energy could assume. Therefore, the electrostatic energy comes to manifest as standing waves which adhere within discrete energy levels or shells, rather than a continuum of possible configurations. In accordance with our previous observations, standing waves are also the results of wave interference. But if the electronic shell is a standing wave formed by wave interference, then this does beg a very important question. What waves are interfering so as to give rise to these electronic spheres? In 1932, the physicist Carl David Anderson of the California Institute of Technology performed experiments using a cloud chamber which was enveloped within a magnetic field. Anderson's aim was to use this experiment to detect different kinds of cosmic rays, which would ionize the atoms comprising the vapor within the cloud chamber, and thus create visible track marks which would correlate with how the cosmic rays interacted with the magnetic field enveloping the chamber. What Anderson found were track patterns which correlated with both electrostatic transmissions as well as another sort of transmission which interacted with the magnetic field in the opposite manner. What this seemed to indicate was the discovery of a new type of quantum transmission event, one which was characterized by the exact same properties as the electron, but with the opposite relation to magnetic circulation patterns. This discovery was interpreted through a lens provided by the physicist Paul Dirac some 4 years previously in 1928. Dirac had attempted to synthesize Schrödinger's quantum wave model with the Einsteinian correspondence of mass and energy in relation to the speed of light. Dirac's model seemed to beautifully synthesize the quantum understanding of wave mechanics with the fundamental correlation of mass and energy, but his model also predicted the existence of negative energy states, as well as anti-electrons or positrons, which would possess the same quantum characteristics as electrons, but with opposite charge. Dirac's findings were initially met with severe skepticism, as negative energy seemed to be a physical impossibility. Nonetheless, Carl David Anderson's empirical findings were clearly quite real. Something had certainly created the track patterns within his cloud chamber, and that something stood in need of explanation. If Anderson's findings were indeed a confirmation of Dirac's predictions, then we must contend with the metaphysical implications of this. What might these notions of antimatter and negative energy indicate regarding the ontological character of electromagnetism? Dirac himself came to develop a particularly fascinating interpretation of these implications. Dirac would propose that empty space was not in fact empty, but rather permeated by a sort of ocean of electrostatic energy fluctuations, an idea which is now known as the Dirac sea hypothesis. According to Dirac, the positron was essentially a sort of hole or void within this electrostatic ocean. The positron, in other words, could be understood as the negation of negation. As we shall see, Dirac was definitely onto something here, but unfortunately modern physics has completely ignored the ontological implications of Dirac's ideas, and instead ran in the opposite direction with his mathematical models, using them as tools within their ever-expanding, incoherent array of fantastical quantum entities. Dirac himself came to be completely disillusioned by this. He insisted that particle physics was completely unjustified in attempting to generalize its models of the electron to include more exotic particles, while the electron models themselves remained blatantly incomplete and unsatisfactory. Closely paralleling these developments in Dirac's thinking, Louis de Broglie came to develop a conception of electromagnetic propagations as consisting of two distinct particles, which we can interpret as two distinct types of field dynamics and their corresponding quantum transmission events. De Broglie believed that when combined together into the electromagnetic wave, these constituents lacked charge, but when separated, would become the electron and the positron. Since the Maxwellian synthesis of the 19th century, it seemed quite clear that light and radio waves were in fact propagations which consisted of both magnetic and electrostatic constituents. As it became clearer that electrostatic transmissions were discrete rather than continuous, the idea of electrostatics as constituted by electron particles came to take hold. Strangely, however, there was no correlative notion of a magnetron as the discrete quantum BB of magnetic flux. This asymmetry was partially due to the advent of Einsteinian special relativity theory, which suggested that electricity and magnetism were in fact the same phenomenon seen from different reference frames. If this were indeed the case, then this would seem to imply that the electron particles could account for both electrostatic and magnetic phenomena without any need for a specialized force carrier of magnetism. This explanation might seem to be quite elegant, but as we saw in the previous video in this series, any explanation of any physical phenomenon through special relativity is a non-explanation, which does no more than delude us into believing that we have achieved understanding when in fact we have not. Any explanation which makes use of an ontologically self-contradictory framework will be an ontologically self-contradictory non-explanation, no matter what sort of mathematical hat tricks are used to obfuscate this. Over the course of his career, de Broglie and his students would continue to develop this conception of the photon as a composite system, but this work would fall into obscurity as the relativistic paradigm came to obfuscate the unanswered questions of electromagnetism beneath the haze of space-time mysticism. Questions regarding the underlying nature of electromagnetism and, by extension, the nature of light were then overshadowed by the ravenous quest for the discovery of ever more exotic and ontologically dubious quantum particles. Yet there are numerous empirical indications that, in some manner or another, de Broglie must have been correct. Within the phenomenon of pair creation, high-energy electromagnetic propagations which interfere with one another can produce a pair of electronic and positronic interaction events. When an electron and positron come together, they recombine to form a photonic transmission event. Given that electromagnetic propagations are comprised of electrostatic and magnetic field waves, and that the electron is the basic unit of electrostatic interaction, what this would all seem to imply is that the positron is in fact the most basic quantum unit of magnetic interaction. If we take the metaphysical implications of Dirac and de Broglie seriously and bring them into dialogue with the Noetic Aether framework we are attempting to develop here, we can see that these implications can bring us even deeper into the fundamental nature of electromagnetism, and thus into the fundamental nature of physical reality itself. As we have already seen, the electrostatic field lines which connect the electromagnetic fields of circuits correspond to patterns of interference. Attraction between the terminals results from destructive interference, while repulsion is due to constructive interference. Likewise, the attraction between opposite magnetic poles is also due to destructive interference. What this would all seem to imply, therefore, is that we are dealing with a force of positive density and pressure, as well as a force of negative density and pressure, the magnetopositronic and the electrostatic. While the positive density of the positronic comes to manifest in fundamentally repulsive manners, the electrostatic appears to be quite literally a kind of vacuum energy, a vacuity, void, or negative density which positive density attempts to fill. While magnetic fields are circulatory systems of etheric density, electrical currents are circulatory systems of vacuity, or negative density. But how could such electrostatic vacuity come to manifest as the spherical standing waves which make up the electronic shells of atoms? In order to further elaborate and clarify our understanding of these phenomena, we must now go even deeper into the hidden world of physical matter, into the beating hearts of the fundamental organisms we refer to as atoms. What exactly is the atomic nucleus? How can we account for the emergence and structure of the atomic world in a manner that remains grounded in what we can actually experience empirically in the natural world? Atoms are known to be composed of protons and neutrons. Protons are in fact positive hydrogen ions, or cations. protons. Free protons are hydrogen atoms which have been stripped of their electrostatic shells. Free neutrons, if simply left to their own devices, will convert themselves into hydrogen atoms over the course of approximately 14 minutes. The neutron will quite literally spit out an electrostatic shell and convert its core into a protonic nucleus, thus producing the two basic constituents of the hydrogen atom. In extreme conditions of pressure or energy density, hydrogen atoms can similarly transmute themselves into neutrons through a process known as electron capture. The hydrogen atom absorbs its own electronic shell and thereby becomes a neutron. We can thus begin to see that all atoms are in fact symbiotic superorganisms comprised of hydrogen. Somehow the combination of the proton and electron becomes the neutron, but what exactly is happening within these mysterious processes? One clue can be derived from the process known as beta plus decay, in which one of the protonic constituents of a heavier atom will convert itself into a neutron, not through the absorption of an electron, but rather through the emission of a positron. It would thus seem that through the emission of the positron, the proton transitions from a 2-to-1 ratio of positronic and electronic forces to a 1-to-1 ratio of such forces. Likewise, electron absorption seems to achieve the exact same effect, the achieving of balance between density and vacuity. What we must take this all to imply, if we are to remain grounded within empirical reality, is that somehow the neutron and the hydrogen atom are composed of the exact same basic constituents which comprise electromagnetic propagations, symbiotically interwoven fields of magnetopositronic density and electrostatic vacuity. And so, how might the same basic constituents of electromagnetic propagations, the same basic elements of light, come to be woven together so as to form stable, self-perpetuating systems which can begin to behave as discrete physical entities? One consideration that we can be rather certain of here is that electromagnetic propagations can be curved. When we look to distant stars and galaxies, we can see that somehow the massive bodies of galactic structures are able to create a lensing effect by bending the paths of the electromagnetic waves which pass through them. This phenomenon is often explained in terms of the relativistic curvature of space-time, and so for obvious reasons I will be bracketing the question of what exactly this lensing amounts to for now. But here we can begin with one simple conjecture which follows directly from the empirical fact of electromagnetic curvature. If such waves can be bent, then this necessarily implies that it is at least possible for them to be bent into circular loops. If light can loop back upon itself, then it can come to form a circuit. Here we must delay the question of how exactly such a situation might come about until more pieces have fallen into place. But we can begin to look at what the implications of this situation would be. If an electromagnetic propagation were to form a circulatory pattern by looping back upon itself, this would result in the creation of a closed circuit in which the electromagnetic field propagation system would begin to continually repeat transmissions with itself. With lasers, we can see that light itself is able to create electromagnetic fields around its own trajectory. A laser will create a cylindrical electromagnetic field around itself which circulates in accordance with the right-hand rule in the exact same manner as an electrical circuit. As such, within a circular, repeating loop of photonic transmission events, what will come to form is a toroidal electromagnetic field. Within such a toroidal structure will come to emerge a conflict between two opposing forces. Due to the inward flow of the magnetopositronic field through the toroid's central opening, magnetic pressure will begin to exert a contractive force which will attempt to collapse the toroid in upon itself. Due to the right-hand rule, however, constructive interference within the center of the toroid will create a repulsive force, which will attempt to counteract this contraction. Ultimately, the contractive magnetic pressure will overcome the repulsion of constructive interference, and the toroid will come to collapse into itself, thereby coming to form a spherical standing wave pattern. We can imagine this as an outer shell of positronic density, which surrounds a central core of electrostatic vacuity. The outer layer of ether density will attempt to collapse into this inner void, and in doing so, the two layers will switch places. The positronic density field will now form a core surrounded by an external shell of electrostatic vacuum. This vacuum will then compel the positronic core to expand outward, and this process will repeat itself in a repeatedly oscillating cycle, a spherical standing wave. If this system were comprised of a physical gas or fluid, then we wouldn't expect such a self-perpetuating oscillation, as the density would simply spread itself out through the vacuum, thus resulting in a homogeneous dissipation. Yet within electromagnetic propagation, such as light waves and radio waves, we can see that the ether behaves in a rather different manner. When positronic density and electrostatic vacuity come together, they never simply negate one another. Rather, they form a dynamic, self-perpetuating system. We can thus infer that within the standing wave pattern I've described above, the gradient of density and vacuity would be maintained even as the two constituents interact with one another. The ether would thus seem to behave in accordance with what we might describe as a conservation of contrast, which ensures that the balance of positive density and negative vacuity never simply dissolves itself into a state of homogeneous nothingness. If I've made myself clear, then it should now be evident that what I have described above is in fact the metamorphosis of the neutron into the protonic core of the hydrogen organism. The electromagnetic propagations form a recursive circuit, which is the neutron, and the conflicting forces within the neutron's toroidal morphology result in its eventual collapse into the spherical state of maximum stability. The protonic core of this organism will begin to emit a continuous flow of etheric radiations from itself. Unlike electromagnetic waves, these propagations will expand as a continuous flow of symmetrical spheres, forming a field of etheric density which will diminish with distance in accordance with the inverse square law, the same law which conditions the intensity of both magnetic and gravitational fields. It is within this radiating field of etheric density waves, or rather mass waves, that the electrostatic shell will come to adhere. These mass waves are of the same fundamental character as magnetic fields, in the sense that both consist of fluctuations of positive ether density. Unlike magnetic fields, however, these mass fields do not exhibit toroidal circulations, and therefore they do not exhibit the polarity of magnetic fields. The field of mass waves produced by the hydrogen organism will propagate in a perfectly symmetrical fashion so long as the proton is moving at a constant velocity. Given a constant velocity, these mass waves will move away from the proton in all directions at the same velocity. Unlike sound waves, which exhibit a Doppler effect when being issued from a moving source, these mass waves will relate to any constant velocity of the atomic nucleus as a resting state. A constant trajectory will effectively be a resting state for the atom, as continuing this trajectory will require no energy. The atom's mass field will not resist this continuity of motion, as the field will be emitted just the same as though the atom were completely stationary. If the atom were to change its speed or direction of motion, however, it would encounter resistance from its own aura of mass propagations until the atom once again achieved a constant velocity and the aura once again recalibrated itself so as to relate to the new velocity as a new resting state. As such, we can now see that this resistance to alteration of resting trajectory is in fact the inertia, and therefore the mass, of the atomic organism. Now we can begin to actually see why mass and energy are effectively interchangeable in the manner that Einstein saw. Mass is resistance to acceleration, and this resistance is quite literally produced by the energy of the atomic organism's mass field. Similarly, we can now see why etheric waves such as light do not have mass. They don't have mass because it is through their activity that the phenomenon of mass comes to emerge in the first place. Transmission events such as positronic transmissions of ether density or electronic transmissions of ether vacuity can transmit mass by increasing or decreasing the inertial resistance of the atomic organism's aura of mass wave propagations, because this inertial resistance is mass. Before moving forward, we should make some quick terminological and conceptual clarifications. At the most basic level, all electromagnetic and indeed all physical phenomena are in fact the dynamic activities of the noetic ether. Magnetic fields result from circulatory patterns of ether density, while electrostatic fields are a kind of void, vacuum, or negative density. Magnetopositronic density is fundamentally expansive and repulsive in character, while electrostatic vacuity is fundamentally attractive and contractive. Electromagnetic waves such as light waves or radio waves combine the dynamics of magnetic circulation and electrostatic interference into a unified recursive phenomenon. Finally, mass waves are the spherical propagations of etheric density fluctuations which define the mass and rest frames of atomic organisms. Atomic organisms are spherical standing waves of etheric density fluctuations all the way down. There is no need nor any epistemological warrant for understanding these phenomena through any concepts or dynamics other than those that are presented directly to us by the actual processes which we encounter within the natural world around us. So now we can begin to answer the question raised by Louis de Broglie's standing wave model of electronic shell formations. If standing waves are produced by interference between wave patterns, then what are the underlying wave patterns which give rise to the electronic shells? Given that the proton must consist of an oscillating polarity of positive and negative ether density, this implies that, assuming there is a perfect balance of the two forces, the proton should create both an outward and an inward flow of etheric density waves. Just as the expansion of the positive density layer of the atom produces expansive density propagations, the contraction of the electrostatic vacuity layer will likewise result in a contractive, inward flow of such density waves through a kind of siphon effect. As these expansive and contractive wave patterns interact with one another, this will result in the creation of standing wave patterns with harmonic characteristics which are defined by the frequency of the protonic core. As protons combine to form heavier elements, they will become nested within one another, like the layered shells of Matryoshka dolls. More outer protonic layers will have lower frequency characteristics, thus resulting in different harmonic characteristics of the standing wave epidermal layers, which come to form around the nucleus. For electromagnetic propagations, neutronic toroids and non-ionized hydrogen atoms, we find a perfectly symmetrical balance of positronic expansion and electrostatic contraction. The phenomenon of ionization, therefore, must be understood as an imbalance of these two fundamental qualities of density and vacuity. When a hydrogen atom becomes positively ionized, thereby becoming a naked proton, the 1-to-1 ratio of density and vacuity becomes a 2-to-1 ratio, as half of the negative density within the protonic core is transmitted to another atom. When this occurs, the outward propagations come to exceed the strength of the inward contractive waves. Similarly, the acquisition of an additional unit of electrostatic vacuity results in an excess of contractive waves in relation to expansive waves. Through such a complementary imbalance of positive and negative ionization, a circulatory flow of ether density can come to form between two atoms, thereby resulting in an ionic bond, through essentially the exact same kind of symbiosis which we see in macroscopic magnets. Here we can thus begin to see that all electromagnetic phenomena are in fact morphogenetic phenomena. One cannot produce half a magnet by cutting a magnet in half because there cannot be half a circulatory system of ether density. Moving electrical currents come to produce magnetic fields because such circulation results in the merging together of the morphogenetic fields which constitute the individual atoms within the electrical current. Moving magnetic fields produce electrical fields because this motion creates patterns of interference between the magnetic circulatory systems and the background of overlapping mass fields, which are being produced by all other atoms and superatomic organisms which comprise our cosmos. The phenomenon of superposition will become much clearer once we begin to incorporate the ideas of David Bohm and others so as to account for the suprageometric nature of noetic, etheric phenomena. In order to do so, we must first look more closely to the nature of light, particularly the phenomenon of refraction, the double-slit experiment, and then finally the results of the infamous Michelson-Morley experiment. Light refraction presents itself, which is something that is essentially incomprehensible within the context of modern materialistic physics. Initially, it would seem that this phenomenon could be understood in a relatively straightforward, physical manner. Light passes through a medium, and this medium then alters the electromagnetic propagations such that the light is bent. But even as early as the 17th century, scientists were already beginning to see that the reality must be much stranger than this physicalist interpretation would imply. In 1662, the French mathematician Pierre de Fermat showed that the refraction of light behaves in accordance with the principle of least time, which we can see as an early form of the principle of least action. What Fermat seemed to show was that the light was not simply being deflected by the medium within refraction phenomena, but rather that the light seemed to be actively choosing the quickest path between its origin and its destination. This, of course, seemed to raise some very difficult implications. How could the light possibly know where it was going in advance such that it could somehow choose the most parsimonious trajectory? Some physicists have taken this to imply some sort of reverse causality, by which the destination atoms somehow transmit information backwards in time to the atoms which emit the photons. But if we look at this situation in terms of a field transmission duality, rather than a wave-particle self-contradiction, then refraction becomes much less mysterious. The electromagnetic wave propagations are fields of possible transmissions, not the transmission events themselves. The former are noetic rather than concrete. While the photonic transmissions occur within geometric space in a physical manner, the field propagations themselves are fundamentally pre-spatial, suprageometric. They do not require time to move through space because although they condition the possibility of transmissions which will occur within geometric space, they themselves are, in a sense, everywhere and nowhere at the same time. The photon takes the path of least time to the destination because the electromagnetic field is, in a sense, already enveloping all possible destinations, and thus including within its structure all of the possible pathways which could be taken by the resultant transmission. During the 20th century, the theoretical physicist David Bohm came to very similar conclusions for a number of very similar reasons. Bohm came to realize that numerous natural phenomena, including the behavior of light, electrostatics, magnetism, gravity, and plasma phenomena all seem to necessitate what Bohm would call the implicate order. Quote, "The essential feature of the implicate order is that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. In the implicate order, everything is connected, and each part of the universe contains information about the whole. In the explicate order, things are unfolded and are seen as separate and distinct. In the implicate order, things are enfolded into one another and are fundamentally connected. The explicate order emerges from the implicate order through a process of unfolding, and the implicate order can be seen as the deeper reality underlying the explicate appearances." Bohm saw that the world which our physical senses encounter is in fact the activity or consequence of a much deeper reality, within which all things are always already interwoven with one another. Physical determinations are therefore not the fundamental substrate of nature, but rather the unfolding of this implicate realm through the concrescence of animate cosmogonic processes. Thus, we can see that Bohm's fundamental insight is the exact same fundamental insight which we have also seen in the works of Henri Bergson, Alfred North Whitehead, Rupert Sheldrake, Goethe, and many others, including Nikola Tesla, who came to see that electromagnetic phenomena necessitated the existence of what he referred to as counterspace, a term which he derived from none other than Rudolf Steiner. The implicate order is a noetic realm of conceptual, formative feelings rather than relations of physical determinations or sensations, of morphogenetic spaces rather than geometrical spaces, of diffuse, indeterminate potentialities rather than of the concrete determinations which comprise the physical, explicate realm. It is, in other words, the ether, which remained ever elusive to scientists of the 19th century who were unable to conceptualize the ether as being anything other than a kind of materialistic fluid substrate. Rather than conceptualizing the ether as a kind of static, fluid substance which physical phenomena swim inside of, it is more accurate to conceptualize the ether as radiating outward indefinitely from each and every entity within the cosmos, as a kind of aura through which all things envelop all other things, thereby conditioning the interactions between them. In terms of physical, geometric space, this is an accurate description, but we must also keep in mind that even this is in some sense an abstraction, as the conceptual feelings which comprise these morphogenetic fields are fundamentally pre-geometric, pre-spatial. They are that which conditions the very possibility of geometric space. So now we can apply this exact same reasoning to the double slit experiments. When a constant stream of light passes through a double slit device, we find, unsurprisingly, that the light passing through the double slit apparatus comes to interfere with itself, thereby giving rise to an interference pattern on the opposite screen. More mysteriously, however, we find the exact same interference pattern if those photonic transmissions occur one at a time. Through the framework of modern particle physics, this is a phenomenon which can be mathematically modeled, but which cannot be rendered comprehensible. It is presented to us as an unknowable mystery, which illustrates just how hopelessly inadequate our pathetic monkey brains are when faced with the whimsical absurdities of the natural world. But through the Noetic Aether framework, this phenomenon seems much more comprehensible. It makes no sense to say that the photons are interfering with themselves because photons are not waves or particles. They are transmissions, which are conditioned by waves of etheric potentiality. Each photonic transmission will be conditioned by the morphology of such propagations, and such propagations are distributed in such a manner that they can indeed interfere with themselves, thereby altering the density or distribution of potential transmissions. The photonic transmissions which result from these propagations therefore exhibit a density distribution which accords with an interference pattern, because the noetic propagations which condition those transmissions are continuous rather than discrete. We see an interference pattern even if one transmission occurs at a time, because every single transmission is the consequence of a distributed, propagating field of potentiality. So now let us look once more to the Michelson-Morley experiment, the monumental observation of an electromagnetic mystery which effectively led to the end of empirical science and its replacement by mathematical fantasy games. The Michelson-Morley experiment was intended to detect the hypothetical ether substrate by detecting the drag effect which it would have upon beams of light. If there was indeed relative motion between the Earth and this presumed ether substrate, then this would imply differences in the speed of light in relation to this relative motion. The null results of this experiment would then lead to the development of special relativity, thus setting the precedent that scientific theories no longer needed to be logically self-consistent, let alone explanatory. But through our understanding of the ether as an implicate or noetic order of potentialities rather than as a static medium, the null results of the Michelson-Morley experiment seem completely unsurprising. The ether which conditioned the photonic transmissions, or beams of light, was not a medium through which the experimental setup was moving. Rather, this ether can be better understood as radiating outward from the light emitters themselves, along with all of the other atoms involved within the experiment. In other words, there was no ether drag effect, because the ether was essentially moving with the experimental setup, because the ether was in fact being produced by the atoms which constituted the experimental setup. We can understand this phenomenon without any need for fantastical contractions of empty space, nor any need for the abolition of simultaneity through the collapsing of time into a fourth spatial dimension. Undoubtedly, there are innumerable phenomena within the natural world which we could attempt to untangle by subjecting them to the theory which I am attempting to develop here, and there are plenty of particular nuances and considerations which we will need to pass over for now. But there is one burning mystery in particular which remains to be unraveled, and through this unraveling, we will begin to see much more clearly the fundamental interdependence of the ether and physical matter. This mystery, of course, is that of gravity. In many ways, science as we know it began with Newtonian mechanics. Newton's work was absolutely monumental in that his mathematical models seemed to definitively confirm the speculations of Galileo and Kepler that the celestial realm operated through the same fundamental dynamics which we see at play within the terrestrial world. The pull of physical bodies downward to the Earth's surface was shown to operate in accordance with the exact same principles which governed the precessions of astrophysical bodies through the sky. But what tends to be overlooked in this narrative is that, even by Newton's own admission, this framework did not provide a scientific explanation for the phenomenon of gravity. Newton provided us with a mathematical framework through which the principles of gravitational phenomena could be depicted and calculated, but Newton explicitly stated that he feigned no hypothesis regarding what gravity actually is or how it comes about. Newton believed that gravity was ultimately a divine force, which therefore could not be explained in naturalistic terms. As we shall see, Newton was exactly half correct in this suggestion. The key insight of Newtonian mechanics was the realization that constant velocities could be regarded as effective states of rest. When we think about the notion of rest in common language, we tend to think in terms of stationary objects. Things naturally gravitate towards the cessation of motion, and therefore it would seem that energy is required to achieve motion. Although we tend to think of Isaac Newton as a mathematical genius, his true stroke of genius was metaphysical, not mathematical. The realization that, in accordance with Galileo's principle of invariance, constant straight-line trajectories were in fact states of rest. Through this alteration of the notion of rest to include constant velocities, Newton was able to elaborate Galileo's perspectival relativity in such a manner that his principles of motion could now be applied to planetary bodies. Celestial objects could be understood as striving, as it were, to maintain constant straight line trajectories through space, which were then curved into elliptical orbits by the trajectory deforming power of gravity. Some 2 centuries later, Albert Einstein would attempt to account for gravity through the generalization of the relativistic space-time deformations implicated by his special theory of relativity. From Galileo to Newton and finally to Einstein, we see the successive development of a common theme: the increasing relativization of perspectival reference frames such that greater universality could be achieved through the further generalization of the principle of invariance. If you're familiar with my earlier videos regarding the historical development of distinct structures or mutations of human awareness, then you will recognize that these developments within physics are in fact the gradual elaboration of the perspectival consciousness, which initially came to emerge during the Italian Renaissance. Moreover, we can also understand this development as a transition from an efficient perspectival consciousness to a deficient perspectival consciousness, one which closely mirrors the epistemological thread which passes through René Descartes, David Hume, and finally Immanuel Kant. Thoroughly analyzing the developments of consciousness which eventually culminated in the birth of Einsteinian cosmology will have to be a project for another video, but for now we can suffice it to say that Einstein's core project was, rather ironically, to save physics from dissolutive relativization through sequestering invariance within the nature of light itself. In doing so, Einstein believed that he would be able to complete the Galilean and Newtonian projects of thoroughly universalizing the principles of physics while also preventing such absolute relativization from completely breaking down objectivity itself. As we saw in our previous video in this series, however, the reality is that Einsteinian cosmology does not actually manage to achieve this, and what we are left with is a worldview in which all reference frames ultimately come to appear as completely distinct realities in themselves, which cannot be reconciled with one another in a logically coherent manner. With regards to gravity, Einstein essentially followed the exact same implicit logic which underpinned Newton's model of gravity. Following Newton, Einstein took for granted that straight-line trajectories with constant velocities were in fact states of rest. Whereas Newton had called upon a mysterious divine force to bend these straight-line trajectories into elliptical orbits, Einstein instead deployed his notion of space-time deformation to achieve essentially the same end. Objects would move in straight lines at constant velocities, but due to the deformation of space-time, these would be straight-line paths through a curved space-time background. Thereby, Einstein achieved the exact same metaphysical goal achieved by Newton in a different way: the goal of treating curved trajectories as resting trajectories in order to account for the phenomenon of gravity. In our previous video, we looked in much more detail at the ways in which Einstein's apparent achievement was a deeply Pyrrhic victory at best, as the metaphysical and epistemological consequences of Einsteinian relativity unavoidably undercut the very possibility of physics as a project of achieving genuine knowledge of an objectively real world. Here, however, I want us to begin to look at what a much more integral understanding of gravity, and by extension, time dilation, might look like. Within our Noetic Aether model, each and every atom comprising our cosmos can be understood to emit a constant radiant aura of mass waves which extend out indefinitely from the protonic cores of the atoms. These auras effectively amount to spherical halos of ether density, which gradually diminish in intensity in accordance with the inverse square law, just as would be the case if the mass waves were comprised of physical gases which decreased in density as they expanded. Recall again that within this framework, we are suggesting that the mass of these atoms actually is, in fact, the effective inertial mass which results from the mass wave propagations which issue forth from the nucleus. The mass fields actually define the resting trajectories of the atoms by essentially defining the path of motion which the atom can continue without encountering resistance from its own mass field. Given that these mass fields extend indefinitely from the atomic nuclei, we can see that the auras of every single atom in the universe will entirely envelop those of every other atom in the universe. Due to this mutual enveloping and the wave-like nature of these auras, we can then infer that dynamics of constructive and destructive interference will emerge between the auras of different atoms. Due to such interactions, the atomic mass fields will themselves come to be altered such that they are no longer entirely uniform, but rather will exhibit a gradient of ether density due to patterns of interference. Consider an atom moving near a massive object such as a planet. The atom's mass field will become less dense in the direction of the planet as the atom's mass propagations will interfere destructively with those of the planet. The atom's mass propagations, which are moving away from the planet, will increase in density as the atom's mass waves and those of the planet will be moving in the same direction and will therefore interfere constructively with one another. As the planet's mass waves encounter the mass waves of smaller bodies, they will initially encounter destructive interference. As the mass waves pass through the smaller bodies completely, they will encounter constructive interference, which will counterbalance the destructive interference initially encountered on the way to the object. These effects will average out in such a manner that the planet's mass waves will continue to accord with the inverse square principle even after passing through other massive objects. Through such interactions, the resting trajectory defined by the atom's mass field will become deformed. The inertial path of the atom will become a curved path rather than a straight line. Rather than utilizing the notion of an unknowable Newtonian force or the notion of space-time curvature in order to treat curved paths as though they were resting trajectories, this framework allows us to see that curved paths simply are resting trajectories. The resting trajectory of a given entity is not determined in a purely perspectival, solipsistic manner at all, but rather comes to be defined through a kind of mutual negotiation which occurs between all of the entities which comprise our universe. What we experience as a gravitational force is in fact simply the tendency of entities to bring themselves into accordance with the resting trajectories which are defined through these mutual interactions of mass fields. In the mutual negotiation between the mass waves of the Earth and the mass waves of your body's resting trajectory comes to be defined as down. You must exert energy in order to resist this trajectory, and so if your legs stop working, you fall to the ground. Thus, we can see that alteration of resting trajectory and resistance to resting trajectory are fundamentally the same phenomenon. Both are forms of acceleration, and therefore Einstein was completely correct in seeing that there was an underlying connection between gravitation and acceleration. The apparent force which you feel holding you down to your chair and the force you would feel when making a rapid turn in an airplane are in fact the same force, the resistance of one's own rest frame. This model, if correct, would also imply that gravitational and electromagnetic phenomena are both emergent activities of the same underlying dynamics of the noetic ether, perhaps implying that gravitational phenomena and electromagnetic phenomena may be able to interplay with one another in ways that are as yet unaccounted for. Beginning in the 1940s, the Swedish physicist Hans Alfvén, winner of the 1970 Physics Nobel Prize, argued that electromagnetic structures and plasma phenomena seem to play a crucial role in the development of stellar, galactic, and intergalactic formations. Alfvén saw that the force of gravity alone was unable to adequately account for the astrophysical phenomena which we actually observe, and saw that the morphological features of the astrophysical realm seemed to imply a crucial role played by electromagnetism, which was as important, if not even more important, than the role attributed to gravity. Despite intense skepticism from astrophysics itself, many of Alfvén's ideas have been empirically confirmed over the course of the ensuing decades. Galaxies do indeed exhibit vast electromagnetic fields characterized by immense interwoven filament structures. Nonetheless, Alfvén's conjectures about the significance of electromagnetism and plasma in astrophysical formations remains largely ignored in favor of theories involving the unobservable and, I would argue, patently non-existent dark matter. But if our Noetic Aether model of gravity is correct, then this would imply that electromagnetic structures within astrophysical systems might actually be able to directly alter the morphology of mass fields by altering their density distributions on sufficiently large scales. It may be, therefore, that the electromagnetic auras of solar systems and galaxies are directly influencing the way in which the phenomenon of gravity actually manifests within such astrophysical processes. Electric universe theory and plasma cosmology might have the last laugh after all, if the thinkers working within those frameworks come to realize that the major problem holding them back has, ironically, been a failure to adequately understand the true nature of electromagnetism and consequently its fundamental interrelatedness with gravity. Before bringing this exposition to a close, there are a number of loose ends I would like to attempt to tie up here, and also begin looking at what the path forward might look like if we are to continue to elaborate and refine this conceptual framework. One issue which we have yet to adequately address thus far is the role of the neutron within the atomic nucleus. As we have conceptualized it thus far, the protonic core of the atom is comprised by nested, concentric layers of oscillating protonic waves. The neutron, however, we have envisioned as an essentially toroidal configuration. What this might imply then is that the neutronic element of the atom comes to form a kind of toroidal mantle which envelops the protonic core. Given what we know about atomic decay, we can then infer that this neutronic mantle provides some sort of stabilizing force to the protonic core, either through the exertion of a kind of contractive magnetic pressure, some sort of harmonic dynamics, or both, though the exact nature of these dynamics would need to be revealed through much more precise and mathematical treatments of our model. On that note, I'd like to call attention to another YouTuber who is criminally underappreciated in my opinion, Ray Fleming. Fleming certainly has his own opinions, which may differ dramatically from my own in many ways, but nonetheless, there is certainly much that we seem to agree upon. Specifically, Fleming has come to very similar conclusions about the morphology of the proton. In this video, Fleming addresses anomalous variations in the measured radius of the proton and attempts to explain these variations by conceptualizing the proton as a spherical structure of rotating dipoles. This model is effectively the exact same as the standing wave model which I've attempted to articulate here, assuming we interpret the positive and negative charge of these dipoles as representing etheric density and vacuity respectively. Fleming then goes on to calculate the maximum radius of such a configuration by considering the limitations of the speed of light and regarding the g factor of the proton as equivalent to that of the electron. In doing so, he derives a maximum radius value which accords with the higher radius values which have been measured empirically, and concludes that the range of distinct measurements is due to the oscillation dynamics of the proton. This could then potentially provide us with a window into how we could begin to mathematically depict the dynamics which are implicated by the Noetic Aether model, and use such mathematical depictions to achieve further-reaching inferences. We could begin to calculate the frequency and density of the mass field propagations which we have conjectured to issue forth from the protonic core, and begin to correlate those calculated frequencies with the harmonic properties of the atom's electronic shells. Thoroughly elaborating this model would also require us to take a second look at Maxwell's mathematical synthesis of electromagnetic theory. If our ether framework is in fact accurate, this implies that the Maxwell equations describe emergent phenomena which arise from much more fundamental dynamics of etheric density, vacuity, circulation, and interference. By attempting to mathematically model these more fundamental dynamics, we could ideally then show in a formal way that the Maxwellian electrodynamic phenomena can be derived from more fundamental principles. Although this framework begins by attempting to redescribe and recontextualize phenomena which are already demonstrable, the framework also carries with it a number of far-reaching implications for cosmology and metaphysics, and stands to contradict many of the ubiquitously repeated dogmas of institutionalized scientism. One very common notion we find within modern astrophysics is that of the heat death of the universe. It is alleged that due to the second law of thermodynamics, the overall structure of our universe will inevitably break down, as the overall gradation of the universe comes to gradually dissolve into a state of absolute thermodynamic equilibrium. The second law of thermodynamics, if taken to be an ultimate metaphysical principle, indicates that the order we see in nature cannot be created, but only redistributed, and that this redistribution always results in a net decrease of the overall order of the cosmos as a total system. This heat death is then complemented by the notion of the Big Bang. Since order, or centropy, cannot actually be generated by cosmogonic processes within this materialistic framework, all of the centropy of the universe must have somehow been contained within the seed which gave birth to it. The universe is thus said to begin as a state of near absolute gradation, and that the entire history of the universe, everything that we have ever known and everything that has ever been, is in fact the gradual winding down of being into nothingness. Terence McKenna once stated that any cosmological theory requires one free miracle, one basic presumption that can allow the universe to actually set itself in motion. The problem with modern astrophysics, however, is that its one free miracle is everything that it is supposed to actually explain. All of the order which we see in the universe has to be contained within the hypothetical singularity at the beginning of time, because modern physics, due to its inherent materialism, can only account for processes of decay, and thus cannot account for legitimate morphogenesis. But even in the 19th century, James Clerk Maxwell had already seen a fatal flaw within this reification of entropy dynamics into an absolute metaphysical principle. In order to illustrate this, Maxwell developed a thought experiment which we now know as Maxwell's demon. Imagine a perfectly sealed chamber filled with a gas which is distributed in a thermally homogeneous manner. The heat of the gas is distributed in a perfectly even manner throughout the chamber. But then imagine that there is a membrane separating the chamber into two subdivisions. Gas particles can pass through the subdivision, but the membrane is able to condition which particles can or cannot pass through it based on their speed. By selectively determining which particles are and are not permitted to pass through the membrane will eventually separate the gas in such a way that the fast-moving particles will be found on one side of the chamber, while slow-moving particles will be found only on the other side. Entropy, it would seem, will have been transmuted into centropy. The common refutation of Maxwell's demon is that somehow the membrane would need to keep a memory store of what particles it has allowed through, and therefore the storage of information itself would result in an increase in entropy, which would counterbalance the apparent increase in centropy which we see in the separation of gases within the chamber. In reality, the arguments surrounding Maxwell's demon and the alleged role of memory erasure are much more complicated than what is typically repeated to us, and I won't be getting into those considerations in detail here. But nonetheless, even if we take these arguments at face value, they only appear to be refutations of Maxwell's demon if we are presuming that the only form of memory in nature is computational, mechanical memory. As we have seen in much more detail in other videos, this assumption would appear to be demonstrably false. If we are to take the works of Whitehead, Bergson, Bohm, and Sheldrake seriously, then we must conclude that memory is in fact a fundamental quality of nature itself. As such, we must then conclude that the second law of thermodynamics is no more than what it was initially intended to be, a principle pertaining specifically to the manner by which heat within mechanical systems comes to gravitate towards equilibrium over time, not an iron law of cosmology and metaphysics. We might then conclude that all truly organic systems, including atoms, stars, galaxies, plasmas, and even metallic magnets, are in some sense or another Maxwellian demons, or rather eidolons, which generate syntropic order from entropic homogeneity through morphogenesis. Modern astrophysics, with its Big Bang and heat death, would thus appear to be, if anything, completely upside down. Cosmogenesis is a process of creation and integration, not disintegration and decay. On that note, we can now return to a question which I left conspicuously hanging earlier on in this video. If neutrons, and consequently hydrogen atoms, are in fact formed via the creation of circular loops of electromagnetic waves, then how might such a process actually come about? As previously mentioned, we do empirically observe the phenomenon of gravitational lensing, which within this context we can interpret as resulting from gradients of etheric density due to mass fields. Under conditions of particularly extreme ether density, therefore, it is possible that electromagnetic waves could be curved into themselves so as to form toroidal circuits. One circumstance within which this might actually take place would be within the mass field of a particularly massive celestial object. Electromagnetic waves would come to be wrapped around the surface of this body. As these loops come to accumulate, then they would eventually come to be pushed towards the poles of the body by forces of density and pressure. As the electromagnetic circuits approach the poles, their circumference will grow ever smaller until eventually being ejected from the poles as a stream of neutrons, which will then collapse into hydrogen atoms. Within the nuclei of galaxies, this seems to be exactly what we see with a phenomenon known as quasars or galactic jets. This would imply then that galaxies themselves are in fact engines of new matter. New matter can create new stars, which can then eventually become new galactic nuclei, and thus engines of ever more matter. So here we can see how matter might be generated within the present epoch of our cosmos. But this still leaves us with the question of how matter may have initially come to form prior to the emergence of the first galactic nuclei. Here we must be much more speculative, but nonetheless I believe that we can begin to piece together a plausible, albeit provisional narrative. So to begin, we must first ask the question of what the overall topography of our universe might actually be. One might surmise that the physical universe might in fact be a truly infinite expanse, that there are an indefinite number of stars and galaxies filling a truly endless spatial void. This, however, would be to misuse the concept of infinity. As Whitehead illustrates in his treatment of Zeno's paradoxes, the infinite, infinitesimal, and indefinite are properties which can be attributed to potentialities, but not concrete actualities. It may be the case that an apple can be divided an infinite number of times in potentiality, but one cannot have an infinite number of apple slices or an infinite number of apples because, strictly speaking, infinity is not a number. So if we are to disqualify the possibility of a legitimately infinite universe, then that leaves us with precious few options. One possibility, at least within the framework of Einsteinian cosmology, is that the physical universe could be folded into a kind of four-dimensional toroid through the curvature of spacetime. Even if we are conceding the highly dubious assumption that spacetime curvature is a physically real phenomenon, empirical observations have failed to corroborate this possibility. As far as our instruments have been able to measure, the overall curvature of space appears to be zero. Therefore, it would seem that there is only one real option for what the overall topography of our universe might be. It must be looped upon itself. Not through the curvature of spacetime, but rather due to the fact that all directions in space ultimately connect with themselves. To quote the great philosopher Isaac Brock, the universe is shaped exactly like the Earth. If you go straight along enough, you'll end up where you were. We could say that although the universe is in fact finite, it is nonetheless indefinitely mirrored in a sense. If we presume that this is indeed the case, and then imagine a primordial state of the universe in which the only dynamics are the fluctuations of ether density within an otherwise empty void, then we can begin to imagine how this primordial situation might begin to dynamically develop due to its own basic characteristics. Any fluctuations of ether density which radiate outward will ultimately come to loop back upon themselves. Due to the closed nature of the universe, in other words, all expansive propagations will inevitably be turned inside out, as it were, to become contractive propagations. Therefore, even if we begin with density fluctuations which were almost negligibly minute, these ripples would come to build upon one another, gradually coming to build an unimaginably titanic vortex of density waves characterized by immense circulatory patterns and complex geometries of constructive and destructive interference. Within the core of this titanic, primordial vortex, electromagnetic propagations would come to be wrapped upon themselves by extreme densities which would come to form. The first atoms would be born, thus beginning the embryonic gestation of the first galactic nucleus. One last nuance I'd like to account for here is the astrophysical phenomenon known as redshift. The term redshift refers to the fact that when we look to ever more distant stars and galaxies, we tend to see that the electromagnetic radiation being emitted by such bodies is ever more shifted towards lower wavelengths. Within Einsteinian cosmology, this is typically taken to indicate the expansion of our universe, that more distant astrophysical bodies are moving away from us ever more rapidly due to the expansion of space-time itself, therefore effectively stretching out the radiations of distant stars and galaxies. Within our Noetic Aether cosmology, however, we can understand this phenomenon in a very different manner. As we have already seen, our ether model of the atom implies that the mass fields of every atom radiate outward indefinitely from the atomic nucleus. If this is the case, then this implies that the apparently empty intergalactic space between ourselves and distant objects is not in fact empty at all, but rather permeated by the overlapping mass fields of every atom in the cosmos. Although these mass fields rapidly diminish in accordance with the inverse square law, they only asymptotically approach zero, meaning that every atom in the universe has a non-zero ether density influence upon every single point in space. Over the incomprehensibly vast expanse of space between galaxies and galactic structures, these negligible perturbations of density would become much more consequential, gradually sapping the energy of the electromagnetic propagations which travel across such vast distances. This interpretation would also better accord with the redshift which we actually observe in galactic quasars. Numerous observations indicate that the quasars within the centers of galaxies tend to exhibit substantially higher redshift than the redshift of the galaxies that they are found within. Within the Einsteinian framework, these observations would seem impossible, given that a galactic nucleus should not be accelerating away from us faster than the galaxy that it is a part of. As such, astrophysicists have attempted to explain away these observations by claiming that they are due to line-of-sight coincidences or lensing effects. But if we interpret redshift within the context of the Noetic Aether, these observations are unsurprising. We would expect far higher etheric density near the galactic nuclei than the galactic bodies as a whole, and this increased density would result in a much more pronounced electromagnetic redshift. As such, we can conclude that we actually have no reason whatsoever to infer that our universe is expanding at all. Our cosmos is growing into being, not exploding into nothingness. So there are also a couple of somewhat tangential but potentially quite significant nuances which I should mention before wrapping this up. One is the nature of atomic photon absorption. Within this phenomenon, atoms are said to absorb photonic particles. Though within the context of our etheric framework, we can take this to imply a transmission of a polar unit of etheric density and vacuity between two atoms. The atom which receives this transmission will be altered such that its valence electronic shell will expand into a higher harmonic energy state. Soon after, this valence electron will drop back down to its original, more stable energy state, and the atom will emit a photonic propagation which will result in a subsequent transmission. Given the understanding of the atom which we have developed above, this phenomenon must imply that the photonic transmission results in the protonic core of the atom becoming lower in frequency, such that the electronic shell resulting from its mass field propagations will expand to a higher energy level with a lower frequency but greater harmonic unrest. Therefore, we can infer that the photonic transmission actually reduces the intensity of the protonic core by expanding the protonic standing wave to a state of larger radius. The protonic standing wave comes to be stretched out, as it were, to a less stable harmonic state, thereby temporarily resulting in lower frequency mass field waves. When the proton then reverts to its more stable baseline harmonic state, the energy potential of the less stable harmonic state is then converted into another wave of photonic propagations. Thus far, I've mostly implied that the standing wave patterns of both the protonic core and electronic shells are simply spheres, but there are reasons to believe that this may be an oversimplification. In order to account for the spin characteristics attributed to the electronic shells, it might be necessary to conclude that these spherical standing waves are in fact spherical vortices, with more complex morphology than what I've thus far suggested. I don't think this complication would change very much about what I've said in this video, but this is something that might be highly significant in attempts to further elaborate this theory. This notion also has precedent in earlier theories. J.J. Thomson, for example, developed a model of the atom as an ether vortex, and so we could potentially look to these earlier attempts in order to gain insight into such complications. So one final phenomenon which I would like us to address here is that of time dilation. Time dilation is certainly an empirically real phenomenon, but one which unfortunately has always been obscured by the fog of Einsteinian relativity theories. As we saw in the previous video in this series, although time dilation is often regarded as a definitive empirical validation of special relativity theory, the ironic reality is that special relativity is a framework which does not and cannot explain any physically real time dilation effects because it cannot explain any physically real phenomena at all. We cannot explain real time dilation by collapsing time into a fourth spatial dimension such that time itself is rendered into nothing more than a perspectival illusion. We can, however, explain time dilation as a physically real elongation of actual durations. If we understand time dilation effects as resulting from real processes that are actually taking longer to occur, then we can begin to develop a genuine understanding of this phenomenon. One major area of disagreement that emerged in the public debates between Henri Bergson and Albert Einstein in 1922 was with regards to the nature of time. While Einstein had come to see time as no more than a stubbornly persistent illusion, Bergson instead insisted that our understanding of time must remain grounded in the empirical reality of time as a genuine phenomenon within nature. Bergson understood time as being characterized fundamentally by what he called duration, a term which we can simply understand as the amount of time required for processes to actually unfold. Bergson saw that memory was absolutely fundamental for adequately understanding the empirical reality of how duration is experienced. As we have seen in far more detail in previous videos, particularly those pertaining to Rupert Sheldrake's theory of morphic resonance, this Bergsonian understanding of memory is very different than the notion of memory as computational information storage. Bergson saw memory as a fundamental dynamic of nature itself and saw that the memory of organic processes was not mere retrieval of stored information, but rather the actual recreation or recollection of past events. Bergson thus developed a notion of a memory cone, a visual illustration of how organisms are able to reach into the past in order to bring the past into dynamic dialogue with presently unfolding processes. Just as Bergson saw a memory cone extending into the past, we should also extend a possibility cone upwards from the present moment, indicating the capacity of the organism to bring future possibilities into consideration within the present moment. Processes which are more animate and thus more conscious are those which have a larger range of possible recollections and considerations of possible futures. The cones thus extend further into the past and future. Processes which are more mechanical, conversely, are those which are more directly determined by the immediate past. The cones are therefore much more truncated, as the consciousness present within such a process is far less intense or lucid. We can see this distinction quite clearly within our own experiences. Actions which we take in a far more habitual, automatic manner are those in which we are simply responding to immediate circumstances in a more mechanistic manner, and the passage of time feels much more rapid. When we are more present for our actions, we bring into play a much broader range of past experiences and future possibilities, and the flow of time is experienced as much more dilated. We can empirically demonstrate that clocks tick more slowly for objects which are moving at higher velocities relative to the Earth. If we take this as an empirically real phenomenon rather than a relativistic illusion, we must take this to imply that real processes are actually taking longer to occur at higher velocities. Yet, if we are to presume that there is no absolute velocity, then this necessarily implies that this time dilation must somehow be occurring due to a contrast between the motion of the high-velocity object and the mass field of the Earth. It must somehow be that time dilation is due to the object's resistance of the contractive power that is the Earth's mass field. Understood within the context of Bergson's theory of duration, we can take this to mean that resistance of the Earth's mass field is actually allowing the memory cones and possibility cones to expand for the animate processes which comprise the object. There is a dilation of time because there is in fact a dilation of consciousness, which occurs for all of the processes involved, including those of the atoms which make up devices such as clocks. Thus, it would seem that relative velocity itself is not resulting in a distortion of time measurement, but rather that the influence of ether density actually contracts consciousness in the exact same way that it physically contracts material objects. At higher velocities, processes come to untether themselves from this contractive power, thus resulting in a dilation of the processes themselves, which results then in longer durations. The dilation of these illustrative cones of consciousness indicates that consciousness will come to quite literally expand. Moments of consciousness will be less bound to the determining influences of their immediate physical environments and will instead become far more receptive to the noetic realm of potentialities as well as personal and collective memories. When we look to the experiences reported by astronauts who have actually undergone such an untethering from the Earth's mass field, their accounts directly support this interpretation. Numerous astronauts have reported immensely profound spiritual experiences which have occurred under such circumstances. Edgar Mitchell, the sixth human being to walk on the moon, reported an experience which he described as samadhi, a state of meditative oneness described within Indic mysticism. Following this experience, Mitchell would go on to found IONS, the Institute of Noetic Sciences, in order to further explore the nature of consciousness. On the Apollo 15 missions, astronaut James Irwin likewise underwent an intensely religious experience. Following this experience, Irwin would go on to become a Christian minister in order to heed the spiritual compulsion which he had encountered. Numerous other astronauts have reported similarly spiritual or religious experiences while in space, and their descriptions of these experiences almost always repeat very common motifs. Feelings of release, expansion, oneness, profundity, and higher purposiveness. Such experiences are often explained as simply the results of how seeing the Earth from a different perspective can cause individuals to be shocked into a moment of epiphany. But now we can see that there may be much more at play here. It may indeed be the case that becoming more untethered from the Earth's influence directly results in a heightened capacity for spiritual receptivity through a literal dilation of consciousness which is fundamentally identical to the dilation of time. Ever since the rise of mechanistic materialism as the predominant ideology of scientific thought during the 19th century, consciousness itself has come to be regarded as a mere curiosity or incomprehensible anomaly within orthodox scientific discourse. Even today, as ever more intellectuals are coming to acknowledge the inevitable conclusion that consciousness must in fact be somehow fundamental to reality itself, such intellectuals nevertheless seem to believe that this acknowledgement of consciousness is no more than a shift towards a different manner of thinking philosophically about the world, a frame shift as it were, which ultimately has no real bearing on our understanding of how the physical world operates. We can have our cake and eat it too, so they seem to suggest, as our understanding of consciousness need not force us to invoke the ire of academic science by requiring us to challenge accepted dogmas. As we have already begun to see, however, this attitude betrays an abject failure to understand just how far-reaching the implications of consciousness actually are. Taking the epistemology of science seriously is necessarily to take consciousness seriously. To take consciousness and epistemology seriously is necessarily to take seriously the fact that the modern scientific worldview has become hopelessly unscientific. If we are to take seriously the very idea of science itself, therefore, then we will be required to re-evaluate essentially everything about the natural world which has been presented to us as factual by the academic clergy. Whether that be our understanding of time dilation, the nature of light and color, the significance of concepts such as entropy and energy, or perhaps most significantly, the true nature of the relationships between matter, consciousness, and biological animacy. As we move forward with this series, we will be continuing to follow the trail laid before us by these implications. We will direct ourselves even further into the history of science, towards the origins of the rupture which developed between materialistic and phenomenological naturalism. In doing so, we will begin to look at the division which emerged between the optical theories of Johann von Goethe and Isaac Newton. There we will look to the phenomena of light, darkness, and color, and the relations between such phenomena and the natures of energy, frequency, and vibration. the fundamental musicality through which we can begin to see the primordial unity of electromagnetism, matter, and animacy. Thanks for watching.